Hello friends, I am Dr. Udhesh Singh and I welcome you to Udhesh Academy. Friends, we are now going to start the course of Mathematics for class 11th. And the first chapter we are going to deal today is sets. Now sets are very important for several chapters. The theory of sets was developed by a German mathematician and his name was George Cantor. And these sets are used to define the concepts of relations and functions, and we use the sets in different topics of geometry, sequences, probability, and these chapters require a knowledge of sets. We have to understand that what is the meaning of sets. The sets are basically the collection of objects of a particular kind. So these objects may be well defined. These objects has to be specific in number, these has to be well defined. For example, if we say the set of pack of cards, then we know that there are 52 cards in a set and that will constitute a set. Similarly, we can say, a cricket team, a particular country. So we know the 11 players of the cricket team, and so that will become a well-defined set. So set is a very important topic, and we will define a particular class of people in a set. Now I will give you some of the examples of the set. For example, there are odd natural numbers less than 10. Suppose we want to make a set of that, of all the natural numbers, odd numbers which are less than 10. Then the set will naturally be 1, 3, 5, 7 and 9. In the same way, we can have a set of the rivers of India, because the rivers of India are fixed, and so if you give the name of all the rivers like Ganga, Yamuna and all these rivers, then that will become a set of all the rivers of India. Similarly, another example is the vowels of the English alphabet. We know that there are 5 vowels, A, E, I, O, U, and this will constitute a set of the vowels of English alphabet. In the same way, the different type of triangles like isosceles triangle, equilateral triangle and different type of triangles, that will also form one type of set. We can have another set, for example, a prime factor of 210. So if we factorize 210, we get another set, and that set will be say 2, 5, then 3 and 7, because these are the different factors of 210. Other will be even numbers, and that we will exclude. In the same way, the solution of the equation of x square minus 5x plus 6 is equal to 0, we can have a set, because if we solve this equation, we get 2 solutions or 2 answers of this quadrilateral equation, and that will be 2 and 3. So if we write 2 and 3, that will become a set of the solution of this particular quadratic equation. So set, as we have seen, is that set has to be well defined. That means you cannot add any number, you cannot delete any number, it has to be specific in number. There are certain situations where the group cannot be well defined. For example, if we say that the 5 most renowned mathematicians of the world. Now, whenever we use some sort of terms like most, best, worst, in that situation it's become a very subjective decision. Now, for example, you ask 10 people to define who are the most renowned mathematician, everybody will give different names, and therefore it is impossible to create a set of 5 most renowned mathematicians, and so this cannot constitute a set. We can have similar examples, for example, the 10 most creative people in the world. Again, creativity is very difficult to define. And 10 most intelligent people in the history of the world, again it is very difficult to define, because intelligence itself is a very subjective term. In the same way, if you say the top 10 best cricketer of the world, now every people will have different cricketers as the top cricketers, and therefore you cannot have a set of 10 best cricketer. In the same way, if we say 10 worst politician of India, let us say, that also cannot be defined, because there cannot be any consensus on this. So in the same way, we can find any examples where there is a subjectivity when we use the words like most, best, then this cannot constitute a set, and we cannot define such type of things in a set theory. Now let's go to the formal definition of set. A set is a well-defined collection of objects. So number 1, it is a collection of objects. Number 2, it should be well-defined. Now when we talk about the terms well-defined, it means there is no scope of adding anything, subtracting anything, there is absolutely zero subjectivity. We cannot do anything about the numbers and the quantity of that particular set. So this is very important. Sets are usually denoted by capital letter A, B, C, X, Y, Z, etc. So you can have any capital letter to denote the set. The element of that set are generally denoted by the small letters like A, B, C, D or like that. So any small letter will denote the element of the set and the capital letter will denote the set itself. You have to also understand that element is also known by different names. The element is sometimes called an object, element is also called member. So elements, member and objects are one and same thing, and we can use different terms depending upon the situation. Now let me give you some examples of the sets which are used in mathematics. For example, capital N. So capital N will generally denote the set of the natural numbers like 1, 2, 3, 4. If you are having these numbers, these are the natural numbers and capital N denotes that. Z is the set of all integers. Now integers are all the positive numbers like 1, 2, 3, 4, it cannot go into the negative side. So that is the set of all the integers. Q is the set of rational number. So rational numbers are those numbers which can be represented in A by B form. So these are the rational numbers, and that is generally represented by a term Q, and R is the term of real numbers. So real numbers are the numbers 1, 2, 3, 4, 5. These are which cannot be a negative number. So and then sometimes we use the the terms Z plus. Z plus is basically the set of the positive integers. Q plus is the set of positive rational numbers, and R plus is the set of positive real numbers. So these are the commonly used mathematical sets which we will be using from time to time in this chapter. Now how do we represent the sets in mathematics? Now if suppose a particular element belongs to a particular set, then generally we say if A is an element of set A, we generally say A belongs to A. That means small a belongs to capital A. Small a is an element and capital is the A is the set. So this is how we normally represent. How do we represent the sets in mathematics? So in the mathematics, the small letter like A, B, C represent the element. Capital letter A, capital B, capital C represent the set. So suppose an element belongs to particular set, then we say A belong to capital A. Small a belong to capital A. That means small a element belong to capital A set. So this is how we represent the set. The belong to word is generally represented in mathematics by a Greek symbol called epsilon. So when we write small a, epsilon capital A, it means small a element belong to the set which is capital A. So this is how we represent the sets. So if suppose a particular element is not part of the set, then we put epsilon naught. This signature is called epsilon naught, and we say B does not belong to A. That means B epsilon naught A. It means that the small letter B does not belong to set A. So this is how we represent in the set form. So for example, if we say V is the set of vowels in the English alphabet, that means we say A belong to V, but B does not belong to V, capital V, that is the set, because small b is not a vowel, while the letter A is a vowel. So this is how we represent the different type of sets. Suppose that P is a set of prime factor of 30, then we can say that 3 belong to P because 3 is a prime factor of 30. But another letter, for example, 15 does not belong to P because 15 is not a prime number. It is divisible by 3 and 5. So it's not a prime number and therefore it does not belong to P. Now there are two methods of representing set. The first method is called roster or tabular form and the second is called set builder form. Now let us first understand what is roster form. In the roster form, all the elements of a set is listed and the elements are being separated by a comma and enclosed in the bracket. For example, if we want to create a set in the roster form of all the even positive integers which are less than 7, then we find that there are basically 3 members in this set, 2, 4 and 6. Then how do we represent? We put a bracket on both the sides, then put 2, 4, 6. This is how we represent the set in the roster form. That means we put a bracket on both the sides and we write all the elements of that particular set separated by a comma. So this is one thing which you should remember. Let us say that we want to have a set of all the natural numbers which divides 42. Then that will be the set, for example, 1, 2, 3, 6, 7, 14, 21 and 42. Now these are the numbers which divide 42. But we can also write it 1, 3, 7, 21, 2, 6, 14, 42. Now you have to understand that the sequence of the number in a set does not matter. That means we can write something in the beginning, something in the last, and the number should not be repeated and all the numbers should be represented. So this is very necessary condition. The sequence is immaterial. In the same way, for example, if you want to write another set, the set of letters forming the word school, S-C-H-O-O-L, then the set will be S-C-H-O-L or H-O-L-C-S. Here you have seen that in the word school, the O letters appear twice, but in this set it will appear only once. So once you have written a letter O, that's sufficient. You don't have to write letter twice. So this is an important thing to understand. The two main important thing, the sequences does not matter. Irrespective of the sequence, the set should consist of all the elements, and number two, that we should not repeat any element. Even though in the original form there can be more than one elements used in the original subject. The second method to represent a set is set builder form. Now how do we define the set builder form? All the elements of a set possess a single common property which is not possessed by any element outside the set. For example, in the set A, E, I, O, U, all the elements possess a common property which is each of them are the vowel in the English alphabet, and no other letter possess this property. That means other than these 5 letters, there is no other letter which can be said to be a vowel, and that is why this is a complete set. If you want to represent this set in the set builder form, we write V equal to then bracket X and then we put sign of colon and we write X is a vowel in English alphabet, and when we pronounce it, then we say that V is a set such that X is a vowel of the English alphabet. Now let's see how we actually say this. You see that V equal to X colon, X is a vowel in English alphabet. When you have to pronounce it, when you say that V is a set, the set of all such X such that X is a vowel of English alphabet. So this is how we pronounce it. Now instead of X we may write Y or any letter like Z, or B, any letter we can write. So this is how we have to learn to pronounce this. Now we'll take certain examples and try to explain the concept of set. Now let us take the first example. Write the solution set of an equation x square plus x minus 2 in the roster and set builder form. So first of all we have to solve this equation, and when we solve this equation we factorize it and we write x minus 1, x plus 2 is equal to 0. So it means that x has two values, 1 and minus 2, and so the set will have two elements, 1. So if you want to write in the roster form, what we do is that we write V such that, and then we put bracket, and inside the bracket we write both the elements, that is 1 and minus 2, and separate that by a comma. So this is very simple. If you want to write the same thing in the set builder form, then we don't have to even solve this equation, and we can write that V equal to x such that x is a solution of equation x square plus x minus 2 equal to 0. So simply write and put the bracket closed, and this is the simple method of writing it in the set builder form. Now let's take the second question. The second question is write the set A, that is 1, 4, 9, 16, 25, and it goes on. So you can easily see that these are the squares of the numbers. So for example, 1 is square of 1, 2, 4 is square of 2, 9 is square of 3, and so on. So if you want to write in the set builder form, what we write is that x such that x is a square of the natural numbers. So this is a very simple method of writing it. If you want to put it in the form of epsilon, then we write that x equal to n square, where n is a natural number. So this is the method of writing the same thing in the set builder form. Let us now take the third example. I am going to give you some of the questions, and you have to tell whether it constitutes a set or not, and you have to justify the answer. So for example, the first is the collection of all the months of a year beginning with a letter J. Now this we know that it is very much a definable term, because there are only 12 months in a year and only a limited number of months start with the letter J. So it is a very well defined term, and therefore it is a set. The second example, if we take the collection of 10 most talented writers of India, and as I have already explained you that it is very difficult to define who are the most talented writers, and therefore it cannot be a set. In the same way, a team of 11 best cricket batsmen in the world, this is again a term which cannot be defined, because who is the best is a very subjective term. Let's take the next example, the collection of all boys in your class. This is definitely a set, because the number of boys in the class is fixed, and so you can very well write their names, and that will constitute a set. It is a well defined term. Then we go to the next one, the collection of novel written by the writer Munshi Premchand. So Munshi Premchand has written a limited number of novels, and it is well defined and well available, and so we can make another set of that. Let's take the next example. The collection of questions in this chapter, and so we know that there are limited questions in this chapter and all the questions can be written, and this will again constitute a set. So let's take the last example, the collection of most dangerous animals of the world. Now you know that most dangerous animals are very difficult to define. Somebody will say lion, somebody will say tiger, somebody will say elephant, depending upon the person's conviction and the person's subjectivity, and therefore it is impossible to define this as a set. Now let's take the next question. Now here is a set A whose elements are 1, 2, 3, 4, 5, 6. Now we have to answer the questions which are given, and we have to put the symbol epsilon or epsilon naught in the blank. Now let's take the first one, 5. So we can easily see that 5 is part of the set A, and therefore 5 belong to A, and therefore 5 epsilon A. Let's go to the second number, 8, and we can easily see that 8 is not there in the set, and therefore 8 does not belong to A, and A epsilon not A. Let's take the third one, 0. 0 is again not there, and therefore 0 does not belong to A, and 0 epsilon not A. 4, for example, 4 is very much, you can see that it is a fourth element, and therefore 4 belong to A, and so it will become 4 epsilon A. Then if you take 2, 2 again is part of the set, and therefore 2 also belong to A, 2 epsilon A. And if you take 10, 10 is not part of the set, and therefore 10 does not belong to A, and 10 epsilon not A. This will be the symbol, and so here are the answers. So friends, I hope that you have been able to understand the basic concepts of set, and you will be able to solve the problems whether a particular set of object actually constitute a set or not, whether certain terms will constitute a set or not. We can use the terms like epsilon and epsilon naught to define whether it belongs to or whether it does not belong to, and we will be able to solve all the problems. Thank you very much for watching the video, and I hope that you have enjoyed watching the video and understood the lesson in totality. Thank you very much.